A list is an ordered but not necessarily sorted collection of data. List may contain 0 elements, single elements, or thousands of elements. When storing data in a list, it's important to know the position of the item in that list in order to access or manipulate them. The position of an item in a list is called index number. The items in a list can be any data type that Grasshopper supports, such as points, curves, surfaces, meshes, etc. So let's jump into Grasshopper and see what are the possibilities of working with lists. The simplest way how to work with lists is by using a panel. So a panel can be easily found in params, input, panel, or by typing panel. It's important to know that panel can be used for inserting information or for displaying information. As you can see in this example, the information is inserted and here is displayed. The way how we insert information, you can make double click and then type any type of information, for example, a number. By formatting a panel, you can decide if you want to multi-line data. Is a way how we can insert information by indexing them. So here we can just repeat this value few times. Every time we press enter, this information is stored in a specific location in this panel. So they have different indexes. You can also decide if you want to draw the indices or not, or even the path of the information contained. But this we will have a look more in detail in future chapters. So let's create a point by using a panel. So here we can directly write coordinates x, y, and z. And then by using the point component, it will transform it into a point. Right now we have only one point, but if we want to have more points in this list, then we need to use the multi-line data and then press enter and type a different value. We can click outside of the panel and we will see that automatically Grasshopper identifies this indexation and returns 3 different points that we can see in space. By using the series components, let's have a look what it's asking for. It's for first number in the series, then a step size and a number of values in the series. So by using the panel, we can give the value to each of these inputs parameters in order to generate a list that runs from 1 till 10. So as we can see, this is the starting value and it goes until 10. So we can change this and then we can always modify this list. There are some components that can contain different data types, like for example geometry. We can set multiple geometries and then we can select this line, point and surfaces. Press enter and now this information it's referenced into Grasshopper. Let's use a panel and see this information stored in this component. We see that we have a curve, a point and a B-rep. So as you can see, panels are really useful in order to display information contained in components. A range is a list of equally spaced numbers between a low and a high value. A domain is every possible number between these two numeric values. So here in this component range, we can use a panel and type the domain that we want to have from 0 to 10 and the number of steps. So this is a different way how we can create a list of values. The strength of Grasshopper is to quickly build and manipulate list of data. So let's have a look in how we can manipulate data that is linked to a specific geometry, like for example a curve. So by using a curve component, we can just set one curve that was created in Rhino, and then by using a divide curve, it's asking for a curve to divide a number of segments and kinks. So this we are not gonna look into detail about. So let's stick to these two first parameters. We see that we have 11 elements counting with 0. This is because it's counting from index 0. If we want to have exactly 10 elements, we will need to always the value -1. So we can display the indexes of these points in the curve. So here we just need to give our points, and we can also optional text size. We have 10 points, and these are the indexes of these points. This is one of the most important part of Grasshopper because allows you to manipulate lists. So if we want to see how many elements is contained in our list, we can simply use list length component, and we can use this panel in order to display the information. This is also very important because it allows us to retrieve a specific item from a list. So here is asking for a list. This is our list of points, and then is asking as well for an item index. So here we can just preview on, and we can also hide this one. So you can see if we move our slider, what we are doing is to select a specific index in this list that it's turned out that is a point. So at the end we are selecting a specific point in that list. We can do some other operations, like for example splitting lists into separate parts. So let's use again our point list component in order to preview how we are splitting our list. So here again is asking for splitting index and giving us as an output the items from the left of this index and the items from the right of that index. That if we change with our slider, we see that we are cutting into a different location inside of this list. So it is very important to understand the correlation between how the information flows inside of geometries and how we can visualize them in different ways. For example, here we visualize it as coordinates, and in Rhino we can visualize it as a geometry itself. So here we can actually change and visualize the other half of the splitted list. In the same way that we can split lists, we can reverse lists. So we can preview this. So here you can see that before we were starting in 0 on the left side and ended up in 9, but by reversing the list, what we are doing is that we are starting with the last item of the list. So let's build up together an example and see what are the possibilities of working with lists in Grasshopper. So here we are using the same curve as before, and we will place two different lists of geometries. So here is a circle and a rectangle. First, we will need to have a curve that it was previously drawn in Rhino, so we can link it to Grasshopper by setting one curve. Let's redo it. And now we can just preview on. So here we will need to divide our curve into equal length segments in order to place our geometries. So by default is giving us a number 10, so 10 segments. If you want to change this value, you can also directly change this by doing right click on the component and type in, for example, 15, or let's say a smaller number, so we will have a bit more space between our points. There are some components, like for example horizontal frame, that can be found in curves, analysis, horizontal planes. So let's turn on this component, and you will see that now by connecting the curve for evaluation, this is our curve, and the t parameter that comes out of a divide curve component, and this is the parameter value at each of the points. So we can use this directly and feed it to our horizontal frame, so Grasshopper knows that this plane needs to be placed at that location in the curve. Since we want to rotate this plane, that means that we need to know where are the axes of our plane. So here we see that we have x, that is tangent to that curve, and the y-axis of this plane that is actually perpendicular to that curve. There is a component that is called Deconstruct Plane that can be found under Vectors, Planes, Deconstruct Plane, and here we can just give our frame. Plane and frames are basically the same thing. So this is our plane to deconstruct, and it will return us the origin point of this plane, the x-axis vector, the y-axis vector, and the z-axis vector. Once we have this, we are ready to rotate. Since the rotate 3D component, it will rotate an object around a center point and an axis vector. So we want to give our base geometry, this is our horizontal frame, is asking us for a rotation angle in degrees. So remember that Grasshopper uses radians in order to control angles in the component. So it's important that if you want to control in degrees your angles, you need to right click on the input angle and select degrees. So now we can use a panel to give the exact amount of degrees for this rotation. We will also need the center of rotation and the axis of rotation. The center of rotation comes directly from the origin of the deconstruct plane. So these are all these points that we have. And we can give our axis of rotation as the y-axis of our plane. Since our y-axis is the green one and we want to rotate along this axis, we can just connect it directly from there. So now if we preview on, we see that we have rotated our planes. Since we don't want to have overlap of information from previous components, we can select all the previous ones and preview off. So now it's much cleaner and it's easier to understand. For our next step, we can just directly split our list into different halves. For this, we can use the same component as before, split list. We can decide, for example, to place any type of geometry. In this case, we are going to place a circle and a rectangle that we can preview on, and you will see that Grasshopper will place the circle in this base plane as a reference. So it's using the first half of the list, and it will only place this geometry where it corresponds to the split list. And in the same way, if we want to see the rest of the list, we can preview on the rectangle component. And now we can move our slider and see how it is possible to decide where to cut this list along the curve, and at the same time deciding what type of geometry we want to place there.